Welcome to the reInvent. Hope you're enjoying it. It's kind of almost the end of it. This session, using tools and agents in generative AI applications, I will try to make it easy for you to understand, and then maybe you will be interested in actually doing that in whatever applications you're creating, or some of you might have already started using that. So let's see if you can, those of you who are experienced can find some still value in this session. I am Navi Kaur. I've come all the way from Melbourne, Australia to give this presentation, specifically for this presentation. That golden jacket you see means I've got all the AWS certifications, 14 of them, and I'm studying for the 15th one, which is recently released, Generative AI Professional Certification. And this breakout session is actually going to help you if you are also preparing for that certification. So what we are going to do is start with an agentic AI, an example of an application which is using tools and some frameworks which are used to build that, and then we'll talk about it. So here we go. Welcome to our GenAI powered investment research portal. This dashboard shows how we are combining generative AI with real-time financial data to create an intelligent investment analysis platform. Financial professionals are drowning in data, quarterly reports, news feeds, market updates, social media. The flood of information from countless sources has become impossible to process effectively. The pressure is intensifying. This creates an impossible choice: be thorough or miss the opportunity. At the top here, you will notice we have live market data streaming in. You can see the API request happening in real time as the system pulls current information from our market data endpoint. We have our portfolio performance chart, risk scores, portfolio values, changes as they happen. Here we have FSI Research Agent. Let's see it in action. The system leverages Strand SDK and cloud models to synthesize multiple data sources, deliver comprehensive analysis in time. Now, watch this. I'll ask about Amazon's stock outlook for 2025, and the agent springs into action, analyzing, then doing research. This typically takes around 45 to 60 seconds. Now think about the traditional approach. You need to open multiple browser tabs, check Bloomberg, Reuters, Yahoo Finance, manually cross-reference data points, take notes, and then synthesize it yourself. Now here's what's happening behind the scenes in this case. The system is systematically, simultaneously querying multiple data sources, pulling real-time market data from our MCP servers, analyzing recent news articles and press releases, and then synthesizing all of this into a coherent analysis. All of this orchestration is built using Strand's agent framework, handled by our model, which act as a conductor, deciding which sources to query. So results are in. Took less than a minute. Comprehensive market position analysis complete with conclusions. Want a summary report? It can provide that as well. You want to chat about it? We can do that here as well. Now let's have a look at our knowledge base. So here we have document analysis system where we can upload, analyze financial documents using AI powered insights. These documents exist in our knowledge base. Here's the knowledge base ID, as you can see. So what we can do here is upload automatic. It's going to automatically transfer this to our Bedrock knowledge base, and it'll start doing the processing behind the scenes. So upload is successful, knowledge base, the sync has started. It saves the embeddings into OpenSearch serverless. Bedrock knowledge base here handles the entire RAG pipeline automatically: ingestion, chunking, embedding, and retrieval. So if we check our library now, we can see the third document is uploaded and it's processing that. We can generate a summary after it's processed the document. We can then chat with it, do our AI analysis with any of these documents, and ask questions in real time as well. The system responds instantly, but pulling it from the knowledge base with source citations included. So we can know that these are the facts coming from these documents, not actually something which it is picking up directly from the outside world. So here the document is ready and I'm clicking on generate summary and it's processing. And very soon we will have our summary highlighted here. So let's have a look at that. Document process ready for RAG queries now. So summary is being generated, but the document says it's ready. So that we can now ask it questions. So this is the document summary from that document we uploaded. And now if I need to ask some questions like what is the revenue growth, it's querying the knowledge base. So the private information we stored, taking that into account, not just the general large language models information. And these are the source citations. Now let's move on to market data, real-time market data. We're using, this is using MCP, Model Context Protocol. This connection is live and persistent throughout our session, giving us real-time access to stock market data. As you can see, service is actually connected to the API endpoint in US West 2, and we have access to market data tools. It's running in live mode. So here I have Amazon's live information. It just updated now. And if I want Tesla's information, I can add that symbol and the stock data will be updated. It has successfully fetched data for Tesla. We can see it in table view as well. So last updated recently, real-time stock data using the MCP servers. Let's go back to the dashboard. This is not magic. It is sophisticated orchestration. We have our models acting as conductor, intelligent caching ensures consistent performance, rate management, MCP servers delivering real-time market feeds via WebSocket. Behind the scenes, there are configurable API endpoints, MCP server connections, strand agents, parameters. So our solution here bridges the gap. This agentic AI application combines document analysis, real-time market data, and AI-powered insights into a unified financial research platform built for speed and sophistication. Thank you.
Right, so that was just an example of what you can build by using these frameworks we have available now, of course using large language model as well behind the scenes. So let's start with our agenda. We will cover some foundation concept, then we will look at frameworks which enable us to build these applications, what is available, and then some of the integration protocols you can utilize as well. So starting with the foundation concepts, because that's essential to understand what is this modern AI systems we are creating. Large language models, if you have heard of them, they're really, really powerful natural language processing. They've got so much information pushed into them that they are really good at analyzing stuff for us, but they do have some limitations. They're magic, but not just magic, they can do much more than that. So LLMs have vast knowledge, but it's static. Training cutoff time has reached, and it only knows about the data which was available till then, nothing after the fact. They cannot perform real world actions. Like if we ask them to go to GitHub and get the demo downloaded or repository downloaded, they won't be able to do that because they don't have that kind of access. LLMs do not have access to your company's private data, something which is not published publicly, it is not available to them. Maybe your HR policy changed recently, the most up-to-date data is not, LLM would not know about it. It might know about generally, there's so many companies in the world, they have their HR policies, this has happened in the past, but nothing about your company's proprietary data. They also hallucinate. They tend to provide you a happy answer. They don't say, oh no, I don't know. Let me find that information for you, and they will make up something sometimes and produce that information about thinking it's real, but it's not. So these limitations means we have to look for other ways to make them useful, to still use LLMs because they are intelligent systems, but how we can make them more powerful. So here we have a user connecting to the client application, asking for a question. Let's say there's a prompt. The client application is now putting that prompt and the available tools available to the application together, sends it to the large language model. Large language model is analyzing it. Okay, what does the user want? What tools I have available? Is there a calculator I can use? It's putting the information together, analyzing it, and then issuing kind of a statement back to the client application. So client application is now told, you have to get it, maybe it is a quiz which we want solved, or it could be an external weather API we want the weather from, could be a mathematical problem needs to be solved. So the language model has some instructions to the client applications, and it is going to go to those tools, get the information from those tools in real time, go back to the LLM, and say, this is my answer, is it good? And language model, it's the brain. It'll analyze that answer again. It'll say, yes, this looks fine. If not, it's going to ask the client application to use some more tools. Do we have access to something else? Use that one. And eventually, it will provide the final output back to the user. So that's kind of how a large language model with the help of tools can help our end user. Some of the common types of tools, first of all, we'll go to this RAG, Retrieval Augmented Generator. It's like a mouthful, but RAG simply means before I go to LLM, I want to go to my own proprietary data and get the facts from there, my HR policy, the current one, add that to the prompt, and then I will go to the language model to say, this is the information, now provide me maybe a summary I'm after, or these are the 5,000 pages, you tell me which one is important for the answer here, you analyze it. So RAG, and we are using that for that vector databases for knowledge retrieval, because vector databases like Amazon OpenSearch, they are fast, they are scalable. So that is one of the tools. Short-term memory and long-term memory can also be provided on the fly by the application to large language model, so that language model, if it is memory about this user already talked to me about something, I have that information, I better look at that before providing an output. Another tool could be the APIs, all the HTTP servers or HTTPS servers or web APIs which are available. So usually as a human, if someone asks me what is the best restaurant around in Vegas, I will go to Google or internet search. Similarly, if we provide these LLMs, these internet available to them, they can use those tools to find the information in real time, just that FSI application in the beginning was trying to do, to go to Yahoo Finance and get the information from there live. We can ask them to generate code for us or utilize some internal code and build something for us as well. So code and shell interpreters, they can use command lines as a tool as well. And then we have all other utilities like calculators. We need the data changed from one form to SQL form or another form. They can do file operations, save the file on my computer, get the file from my computer, all as provided to the LLM as tools for them to use those operations and then provide relevant output. So from tools to agency, the AI agent, this is the picture here, which tells you, which demonstrates how an AI agent is not just a language model anymore. It is much more than that. It has now given systems to make it capable of providing information in real time, still using natural language processing, and do that with these extra things in the application like memory, tools, and giving goals to it as well. One of the frameworks which is used to build these applications is called REACT, Reason and Acting. So here when our client application takes the prompt from the end user, goes to the LLM, LLM looks at the prompt and say, okay, he's asking for this mathematical calculation. I don't want to hallucinate or try to work it out myself. Is there a tool available to me? And then it's asking the application to go to that tool. Come back to me with more information, the answer for this mathematical calculation, and then I'll check it again. So it's like a cycle, as you can see here, reasoning, acting, reflecting on the provided output, and then observing again. The cycle only completes when LLM is happy with the answer itself to say, yes, this makes sense. I think this is what the user was about, and I'm now going to, you can provide the final output to the user. So each step, large language model and the tools are involved. So growing demand for these agentic applications means a lot of scripting, a lot of coding for the developers. But we don't have to start from scratch. And we have used the frameworks in the past as well, like Python, SDK, and Boto 3. All different languages have their own software development kits. So these are the frameworks which we can use to make our life simpler before we create these applications. So let's look at some of the agentic frameworks which are available to developers to create the agentic AI applications. So we've got a few here. So it is important that you choose the toolkit which you're most comfortable with, which gives you more flexibility and maybe options, different features. So we have Amazon Bedrock agents, which are fully managed serverless service that Amazon offers for the AI agent deployment. You can create agents using Lambda functions and then use them for your AI application. But there are many open source frameworks as well, like Strands Agent, Crew AI, and LangGraph plus LangChain. So let's have a look at those open source frameworks today. We'll start with Strands Agents. So this is open source software development kit. It used to be Amazon's own developers were using it a lot, and then we have open sourced it, so now anyone can contribute to make it better as well or use it. So this one is model-driven agent deployment. So basically the model decides here, just a few lines of code. You don't need to write a lot, it abstracts away a lot of things. So it's simple to write, and you will see that in the demo as well. You can use it for your local development, you can use it for microservice agentic AI applications or even hybrid architectures. It has inbuilt open telemetry, the monitoring part of it is also inbuilt, so easily integrated into the same application framework when you're writing it down. So 3 main components: model, tools, and the prompt. The model provides the intelligence, the reasoning capabilities. The tools are the ones which are actually connecting it to the real-time world or doing the actual functions. They allow the agent to take actions. Prompt is agent's instruction manual. We tell it that this is who you are. Act like this technically trainer maybe. So telling it how to behave, make decisions. That's why the prompt. So prompt can also provide some specific constraints. Don't do this. Don't use red color. Things like that. So here is our application, the Strands Agents workflow. We have a prompt which is invoking the agent. So that's like a question. If you are not clear about what a prompt is, it's like an end user is asking something. So it's a question from the end user, and it goes to the agent. Agent says, okay, I will invoke the model, give it all the information I have, and let model decide what is the next step. So model says, use this tool, not that one. There could be hundreds of tools available, and then model will decide which one to use. It'll send it back to the agent, which is doing all the action items, bringing the answers back, going back to the LLM. LLM says, no, I don't think this is good enough. I need some more information. Go back, use the other tool, get the information. And then finally, the LLM decides this is the final output. You can provide the results to the end user. So just as a DNA has 2 intervening strands, That's like a blueprint, life's blueprint. This framework has two fundamental strands that work together. As you can see in the picture, one is the model, one is the tool. So as simple as that, this is actually what the framework looks like, just in a few line of code. So you're looking at a code snippet. It's telling you how AI agent is using the strands framework. Up on the top, you can see we are importing some libraries. So here we have Python replicator, and then we import the agent and the tool itself, and then the bedrock model. So in this case, strand agent actually by default uses one of the models from the bedrock, but it can use any other open source model as well as another proprietary model or even local model from your laptop. And then we're defining the agent and then the response. So let's have a look at one of the examples of this code. So here I am in Jupyter Lab Notebook. This is within Amazon services, AWS console. I went to SageMaker AI, and then I opened up the Jupyter Notebook. We look at the strands agent first. Okay, so what we are doing here is building a recipe assistant, because that's all, we all need that these days, so we don't have to call Uber Eats all the time. So practical recipe assistant, let's see how practical it is. So first cell, I'm just going there to install some of the tools here and play that. And these are just warnings, so we can ignore that. Now, one of the tools I'm going to give to this agent, the recipe agent, is to do a search in real time and get information from the outside world, and that's why we are installing this DuckDuck search. I'm just going slow so everyone can have a look at what we are doing. Very simple. Is it the font okay from here? And then, like we saw the code snippet, we have got this strand importing the agent tool and the DGGS, which is DuckDuck Search Go, and the bedrock model is then defined. We are using Amazon's Nova Lite version 1, and then our tool. We are giving it the information. So this is just an example of one tool, but as I said, you can have hundreds of tools provided in your agentic AI application. So this tool is about web search, and just very basic. I've kept it very basic, not too much of code, but you can put in all the things like ignore the warnings, catch all different kinds of errors, up to you when you're developing your application. This is just for demo. So here we are creating the recipe assistant agent. It's given a system prompt. It's been told what is its job. You are a recipe bot. You can name it whatever you like. A helpful cooking assistant, so try to help instead of saying, no, you can't cook. That provides concise responses. So some of you, if you have studied about the pros and cons of generative AI models, would know why I provided twice in there. I said provide concise responses, plus find one popular recipe. I didn't want it to go crazy and give me hundreds of recipes, because that's what it can do. It's verbose and chatty by the nature, the models. And the tool given is the name of the tool. In this case, is just web search. And now let's test the recipe assistant. It's a live demo, and hopefully demo gods are with me, because you never know what happens with the internet. So here I'm just asking you to suggest me a simple recipe with chicken and broccoli. I'm actually giving it a little bit hard work to do, and then again in 3 lines. I tested it, and every time it just gives me big recipes. I said, no, I just need 3 lines, good enough. I will know what to do with that. And then chatting with the assistant, you can ask it more questions as well. Okay, so let's go back, run this cell. Imports are done. It understands the prompt now, and the question has been asked. So this star means it's working on it. It's going to look at the prompt, take it to the LLM, LLM decides, ask it what tools do you have, I've got web search, okay, go and then do the web search, get the response. Okay, still going. So while it's waiting, does anyone remember the name of the model it's going to use? Where is it asking this question? Version 1. Is there a version 2 available? Excellent, yes. Yes. So we have released the newer versions of the Nova family.
Can you explain us about tools? Like we are using the tool, right? What is this tool is? Like what kind of tool we can use, etc.
In here, in this example,
Well, I want to know like how other tools we can use. Like what are those tools available?
sure. Let's chat afterwards. Yes, I can give you some information so you can look up those tools, what different tools you can use. Okay, while we are waiting, it could be a web search, depends on the query. It could be you want information from a database, so your database is a tool. You want information from your local desktop. On the C drive, you have some documents, that could be your tool. So there could be hundreds of different things. It's same as when we want some information. I ask you a question, you will look at different stuff, like maybe your phone, that's a tool for you, or you might do a search on Google, that's a tool for you. So tool is just where you're getting the information from. So it depends on what tools are available, which ones you want to use and you trust. Okay, so eventually it was able to find one simple chicken and broccoli recipe, and tool 1, it searched number 1 tool. So if there are 20 tools, it will show us if it is what tools was it looking at, where it was getting the information from. So I am not happy with the recipe, don't want soy sauce in it, for example. So you can still chat, and then it is endless. It depends on, after you understand the concept, depends on you how you want to create your applications, what is the end use case of your application. So this one is a chatbot, so I say, no, broccoli, I want any other green vegetables I can use. Not here, supposed to be in here. And it can just find that information again and it'll go and chat. So again, an asterisk, it's working on it, trying to find other green vegetables for me. I don't know if we put green vegetables in chicken. Does someone do that? No, maybe just onion, tomato, red vegetables. And sorry if there are vegetarians in there, my example, bad. Okay, but I hope you get the point, yes, because this is going to talk to me and tell me all about different vegetables. And I wasn't asking it to be concise this time, so it'll just spit out a lot of text. So let's go. Yes, because previously I had like one recipe. Yes. Yes, I only gave it one tool because this is a recipe bot. It doesn't need like calculator or a database. Yeah, I can't hear you properly, but yes, so whatever you define, and it's all about as a developer, what we are asking it to do, and it'll follow that. So do you want me to go up a little bit to say which? So where max results from what? This one? Oh. It's controlled by the person who is writing the script, so we can. I just wanted it to be not giving me 20 recipes, so I just says result. We can ask LLM to decide as well, yes, yes. It's like, it'll listen to you, whatever you're asking it to do, it'll be happily doing that. But if you are asking it to give you real-time information, it will not be able to do that, right? So that's why we're giving it tools to do it. But yes, I can, in this system prompt, I can tell it whatever I want it to behave like. Okay, it was a long wait. Too many connections, it's saying. Everyone's trying to use Nova. Anyway, let's go back to our PPT. So here we saw Strand agents. The whole point here, it has many inbuilt tools as well. So we don't have to define what is a calculator, what is the Python replicator. It knows that. It can just work directly with that. But in my case, I defined a tool called web search and told it where exactly which API to hit. Similarly, we have Crew AI. It is also open source framework. It is built in Python and provides enterprise level capabilities, just like Strand's agents, to build the agentic AI applications, providing developers all the flexibility they need. So it has Python foundation, and that's where most people love it. Python, easy to use language as well, easy to learn. So open source again, and it supports both individual AI flows and multi-agent architectures as well. Collaborative intelligence. So when we set it up an agentic AI application using Crew AI, the name Crew means it can work with multi-agents as well. It can tackle complex tasks with the help of that crew it has. So multiple AI agents working together, coordinating their efforts, achieving the goal you want. With Crew AI, we have crews and flows as two separate things you can use. So the diagram up the top tells you that the crew is working together with the help of agents, tools, tasks. You can define the tasks as well. You can give it a role and then it forms the crew with what it has available, and then it works with them. With the flows, it is providing more precisation, so more flexibility of how you want to drive it, what you want it to start with, what tasks you want it to do in parallel. So more information, more flexibility as a developer you have. And you can put in conditional logic. So you might have seen something like that in one of the AWS services step functions. So similar to that, this one is more on, this is the flow I want. I want it to move like this. And LLM is still going to decide about it, but as a developer, you have also decided the flow. So more control. This is a code snippet for the Crew AI framework, how that works. So from the very beginning, as you can see, again, we are just importing the libraries. So abstracting away a lot of stuff from, instead of building everything from scratch. So we have the tool here as well, the same tool, DuckDuck search engine, and then we define the tool, why we are using it, and what is the purpose of the tool, then configuring the large language model. So in the example here, we have got Sonnet 4, and then defining the agent. So it needs the LLM, needs the agent, then we go down to define the task. Why is this, what is this application about? So what task we want it to do, we can define it. And let's look at the example of the Crew travel research agent we have here. It's going to find you the dream destination. So we are using Amazon Bedrock model here. That's why it says with the help of Crew AI and Amazon Bedrock. So these notebooks are available on GitHub as well, like if you want to later on try that for yourself. So here we are installing all the necessary libraries again. So let's go run this cell. So Crew AI, LangChain Community, Boto 3, and a few others, importing all the necessary stuff. Agent, task, crew, which makes up the whole crew framework. We are also using the DuckDuckGo search, and that's why we've got a LangChain community tool. This is one of the community tools available. We can use that. No need of any authorization for this. So defining the tool. So every time that prompt goes to the LLM with the information about different tools it has available, the LLM needs not just the name of the tool. It says, okay, what does this tool do? I don't know. Is it a calculator? It's easy to understand, it calculates. But if I name my tool as my own database, LLM doesn't know what is in that own database. So there is a description is great. It helps LLM understand what our purpose, what is the concept, what it is all about, what our intent is. So that's what it says here, search the web for information on a given topic. Now, configuring the LLM. With the Strands agent, even if we don't configure the LLM, it defaults to the Bedrock model, Claude. But here in Crew AI, you need to specifically tell which LLM large language model you want to use. So we are using 3.5 Haiku, and now we are defining the agent. So this little application is a travel destination researcher. Just research it, matching the user's travel preferences. So we have given it a role. Very important for LLM to know what my role is, because how should I behave? It's like a persona we are giving it. Goal. What is the end goal? What I'm going to do here. So it's like when we are teaching our children, we say, okay, this is what you have to do. You have to finish your homework. By this time, you're explaining all the steps to the child so that they understand. Otherwise, if you just say, go do your homework, they will do one sentence and yes, I did my homework. It was just one sentence, but I did it. Didn't complete it. So here we have a backstory as well. So it's a personalized travel recommendation for the user. It could be as long as you want or as short as mine, just because this was a demo. And there are a few other parameters, variables we can do, give it, and then we are telling it which tool is available, the name of the tool. We have already defined the tool earlier. So let's actually start running the cells as well. So imported all the libraries, we've defined the web search tool, told about which LLM to use, and all about our agent in this case, travel agent. Specifying the task. Crew AI expects there has to be a task as well. What is I'm supposed to do? So description of the task, even expected output. Or we can give an example to it as well, like this is the example, this is how you should provide the output. And telling the name of the agent, which we have already defined earlier. So Crew AI framework is now ready to create its own crew by what it has available. It has got agents, which is just one in this case, but it could be a multi-agent application. If that required, then we are going to name all the agents in this field here. We are telling it about the task, and verbosity is true here as well. And then it can, so it's ready to go. I haven't made like a chatbot or anything, so just one example here. Let's execute to see how it behaves. User is inputting this information. I want a tropical beach vacation. And the result is when the crew kicks off. Vibrant nightlife. I'm sure it'll say Vegas, but I don't think there's any snorkeling here. So execution has started. Then it depends on, remember the verb was equal to true, so it can give you a lot of logs as well, and which is really good for in the operation sense to figure out if there was latency, how quickly it came back with the answer, or was there an issue, the problem. It will log all that, and it is doing that here as well. So crew execution started. Travel destination research based on the user's travel preference, because that's what it's tasked. So this information is now available to large language model to decide what should be the next step. And it's okay, sometimes it does that, it's trying to do that, the call fail. Oops. Usually towards the end, it tries multiple times as well, and then it works. Here it's saying the access to the Bedrock model is not available anymore. So let me log on again, because it's timed. The single sign-on is only timed. So I'm just going to log in again so that my user has access. I did that maybe 3 hours ago, so it's not working anymore. But it's good to do troubleshooting, especially when I know it'll work. So just the model access is important because it's accessing my AWS account to talk to the LLM. Okay. Let's execute again. Okay, so we have the star, it's working, crew execution started. Using tool DuckGoGo search, and then the tool input. What was that tool's description? What is it trying to do now, getting that tool to work? So first it goes, no good search results were found, and it'll keep doing that for a while. Finally, it did find something, top hat. It's still generating the final answer. Just keeping me busy in the meantime. Okay, great. Mexico, it says. Anyone here from Mexico? Is this correct? Is that a snorkeling? Yeah? Great. Does it have a nightlife as well? Not same as Vegas, though? Yes, great. Anyone from Thailand? Okay, but I trust the LLM. I don't know where Aruba is. That could be a next destination. So just picking up a few and then it's coming back, but I think you proved that it is definitely correct with the Mexico example. So that was Crew AI, and this is just a simple example. It could be now open to you all these other things where you can use Crew AI very simply, open source framework, so a lot of contributors always making it better and better and better. So, but use that to create your applications and use tools in it. So similarly, another open source framework and very popular as well is LangChain. So LangChain came around a few years back, and it was like most stars on the GitHub and become very, very popular. Everyone started using it. I had to learn from scratch, but I was happy to do that. So it is your go-to straightforward linear workflows you want. You use LangChain for that. It has these components again. It has chains. You can have memory embed, which is those databases where you are keeping the long-term chats of your users or their preferences, or it could be just for the short term when the chatbot is talking to you. It needs the prompts, LLM, of course, because these are agentic AI applications. Without a model, they are nothing. They are simply web app then. You can create your agents and tools in the LangChain. LangGraph, on the other hand, is where you need complex, stateful workflows. So there are edges and nodes in the LangGraph, and LangGraph is more about managing the whole state as well. It can go back. say, okay, I've done this, but I have to now do that action again. So you can create this framework where easily you can build up these human in the loop as well in that same state management. So similar to what we saw earlier in the crew AI flows. So more flexibility in creating using LangChain and LangGraph. And many people have created so many proof of concepts using LangChain and LangGraph. So these are some of the frameworks. Managed services like agents, Bedrock agents also help you with creating these agentic AI applications. Next up, we have integration protocols. So these are also essential building blocks for connecting different systems, different applications seamlessly. So let's have a look at what is available with this and why why the need. Agent interoperability is important as well, because as you start building more of these systems, there is a new problem. You have so many tools, you have different agent frameworks you want to use, and you want to connect those agents to different tools. What kind of approach you should have? If it is a standard, we are all happy. If there is no standard, you're connecting each tool with a different unique API. It's a lot of work, not just in the beginning when you're connecting to different tools, but then doing the maintenance of those tools as well. Then another department in your company start creating agents and adding those same tools to their agents. They have to start from scratch as well because there's no standard. So we need a standard to make our work easy. We want to have some frameworks for agent interoperability as well. So first solution is Model Context Protocol, MCP, getting really, really popular. It provides a client-server architecture. So what MCP is, a standardized way of connecting your AI application to different tools. The tools could be anything, databases, APIs, calculator, but how you connect your AI application to that tool is in a standard way. As you can see in the picture here, we have the agent wants to talk to different tools. In this example, AWS documentation. To connect to AWS documentation, there will be an API, and if I connect to that API and AWS changes something on their end, I'll have to know about it and connect to the right API, the current one again. So a lot of work. Instead of that, AWS documentation side will maintain their standard. On my side, my agent will have a client MCP, its own standard. So if we are connecting to each other with common standard in a common way, no one will have issues. So here we have a unified way. MCP agent has MCP client, and AWS documentation has an MCP server. And when I say server, it's not like an EC2, it's like a process which explains how to connect to me, what tools I have, what features of these tools are available, which you can use. So before MCP, every AI application needed custom code to connect to different services. Not anymore. Similar to, if you remember the day when the USB-C came along, we now don't have to connect to any other things like HDMI cables or anything. We don't need to look. All our laptops have USB-C. All the electronic iPads have the same kind of connection we can use to connect with the same connector. So let's look at an example of how this inter-agent pattern works. So on the left, I've got an agent which has an MCP client. This is an HR agent, so it will talk about HR policies. This MCP client is ready, up and running with this agent. Now the HR agent needs access to a tool. It wants to get some information, for example. So it will connect to the employee info agent, or it wants to connect to some kind of function. It needs to look into the process documentation. It'll ask the MCP server, what way should I connect? What are your current ways to connect? MCP server is ready. It said, yes, something was changed, but I know. You just need to talk to me. I will tell you exactly in a standard way you can connect. You don't need to change anything from your end. So MCP client is communicating through this central MCP server. MCP server manages the message routing. An HR agent can invoke that. Now in this case, there's another agent which is employee info agent. That employee info agent also has access to his own tools. To talk to those tools, it'll say, I have an MCP client as well. I will just talk to you in a standard way. That employee database which is sitting there, maybe APIs have changed or there is something unique, some changes were made. I don't care. I will just ask the MCP server and say, oh, how do we connect? So that is like the common standard way now. We have MCP client talking to MCP server. The employee data store, we can change. It is providing persistent storage capabilities. We can look inside the database, run an SQL query like we previously used to do that. But our application says, I want to connect in a standard way, and that's where MCP is handy. I'll keep it here for a second for you to, if you have any questions about this MCP, Model Context Protocol, like what is the purpose? Is that clear? Have you heard about Amazon Q Developer? Anyone? Yes? Okay, great. Kiro. Definitely, yes. All right, maybe I should show you a little Kiro where I have MCP servers connected and we can chat to them. So Amazon Q chat I am using, I'll show you in a second while it warms up. Amazon Q has inbuilt MCP client. We don't need to install or run anything because it has inbuilt MCP client. It has LLM access to the Claude model, all inbuilt, and we can give it MCP servers to say AWS documentation. When I ask a question to Amazon Q, I say, okay, I need Lambda's latest runtime. What is it? I don't want LLM to tell me what the runtime is. I want that from the documentation. It can connect to the MCP server, AWS documentation, and get the information in real time. So let me show you the demo now. So here we have Kiro. I'm not going to use Kiro's MCP server. I like the Amazon Q ones more. So this is AWS Knowledge MCP server. So if I ask Amazon Q a question about the knowledge documentation, it'll go there and get that. Then I've got this one here, Bedrock Knowledge Base. In my AWS account, I have knowledge bases, my private data in the Bedrock service. And when I ask it a question, I don't want it to go and answer from the LLM knowledge. I want it to go and talk to my knowledge base. But how have I connected? Using Model Context Protocol, which is like a standard way of connecting the APIs. So I'm not just asking it using MCP. Usually it obeys, it will find yes. So it is going to do the MCP, AWS documentation search. And it's already actually done it, so really fast. But it is going to my documentation outside, not giving me information from its own knowledge. It's not about getting the information in real time, it's like working as a tool for me, but it's about the standard way of connecting to these data sources of outside of the LLM. So that was connecting to our tools. Okay, so keep that in mind because next one might confuse you if you don't. So we use MCP to connect to our different tools. Now we also have another solution, another framework to integrate for interoperability called A2A, agent to agent protocol communication. here we have a user asking a client application a question. So that's our application, which has LLM in it. It has access to multiple tools as well. And this client application provides the answer. I'm fine, I can book your flight. I have all the details about different flights. And here you can have your schedule as well. But what if this agent now asks to book the hotel as well? I built my agent A only for the flight booking. It cannot do anything more than that. But the user is saying, can you also give me hotel booking? So my agent can actually look around. I've given it flexibility. Look around, see if there's another agent out there. It could be built by my team, another team in my company, or maybe another company outside. Software as a service. So agent A says, yes, I can see agent B who can do hotel booking. How do I connect to it? I need a standard way to connect to this agent A to get myself authorized, authenticated, and ask it the right question. I need a hotel booking in a particular city. So agent B is out there. It goes, yes, oh, look at my agent card. And that's how you recognize me. I can do that hotel booking for you. You can come, and this is the list of my skills, my service endpoints. This is how you need to authenticate to me. And then I will do that hotel booking for you using my own tools. And how that agent is connecting to those tools? Using MCP, using a standard way. But this one here is A to A communication, agent to agent. Agent with its own tool, agent A, is happy doing flight booking, but doesn't have any other capabilities at this moment. We haven't built that because another of my colleague, they do the hotel booking agent. So I say, yeah, I'll use that. Depending on the agent card, I can have access to that. So here, another example, agent 1. It has local agents, it has tools available to it. It's using agent framework. Maybe it's built using Strands framework. It has access to it has an LLM, and now it's looking for some other agent out there who has its own tools, own LLM. They can connect to it using standard protocol. So just facilitating communication between these agents in a standard way. So it's the same way like it's happening in this world right now. So for example, I go to Facebook, I need to authenticate. But here's my agent authenticating because you authenticate with Facebook because Facebook allows you to create a user ID and a password to log in. Similarly, this second agent will be roaming around with the agent card to say this is the way you authenticate. So machine-to-machine authentication. There could be multiple ways of. So here's a chart of how to choose the right protocol because they're both serving different purpose here. We just need to understand that we don't need to choose between them. We can choose both for our applications, especially in these agent-based systems. So we have MCP designed for tool orchestration using client-server architecture. So your agent is interacting with different tools, local tools or APIs, databases, in a hierarchical manner. So best suited for scenarios which require unified access to various tools and services. In contrast, we have A2A, which focus on enabling direct collaboration between different agents using peer-to-peer communication. It's like, okay, I have a flight booking access, you can do hotel booking, help me out. And there could be a third agent I have built, and I'm saying, my agent, you can authenticate, come to me and ask questions if you want. Of course, there might be like a payment method. I want you to pay for this service, and I can find research destination. I can research the destinations for you, what to do, where you're going. So that could be a third agent. So ideal for unifying access to the tools, and the other one is for distributed task delegation. We don't have to build one agent which can do hundreds of different things. We can have different agents doing different things, even in our own company, but have a method of them collaborating with each other. So key takeaways here, let's recap that. LLMs don't operate in isolation. So they can interact with external systems. That's what makes them truly useful, especially in production environments. The React framework, which we looked at, where AI agents are reasoning and acting, that's like a structured approach. So AI agent reason through the problems, step by step, then decide which tool to use, and then make sure the answer is what is relevant for the user, and then provide them the output. You don't need to build everything from scratch. That's why these frameworks exist, like Strands agents, Crew AI. They help you speed up your development work. LangChain, because they provide pre-built components and abstractions. Standardization matters, and that's where we have these interoperability tools like protocols like MCP and A2A to help us with. Thank you.